Okay, so this is called Tracker software, and I want to do a quick tutorial about how to analyze a video using Tracker software. Okay, what we have to do then is we have to drag a video file into here, and my video file was here. So you got to find a video file. I'll email you this somehow, and drag the video file into there, and it'll load it. Okay, so it'll just take a few seconds to load. Can you guys see how it says frames loading right here? What a video really does is it just takes a whole bunch of pictures all in a row. And then when it plays them all in one big swoop, we just we see a video. But really, a video is just a whole bunch of pictures. When I took a video of Brady dropping this thing right here, I'll play it for you guys to see. So hopefully it's playing in a second here. There are, down along the bottom somewhere here, it'll tell me how many frames there are. It's going to take a long time for us to get through all the frames here. You guys see how it's on frame 77? Like it's taking a while for him to get there. Let me fast forward. So this is now picture 145. Still hasn't dropped it yet. We're getting there. Ah, there we go. You see how he finally dropped the basketball? Okay, so when you guys want to do this yourself, that's why I'm recording a video here. Let me show you how to analyze this video. It's actually really easy. You just need a tutorial. Okay. First thing you want to do is upload your video. And then you want to figure out which frames right here are actually the frames that we care about. So would you guys agree that up until here, he hasn't even dropped the ball yet? And somewhere around here, he's about to. Okay, I think he finally just dropped it. You guys can see in slow motion. How cool is that you can actually see the second here, the ball is in his hands, right? And if I click to the next frame, one frame at a time, I'm going to find it. I think it's still in his hands. There. Can you guys see how his hand moved there? Here to here. Okay. The way we do this is that's on frame 162, it looks like. I'm going to drag this little slider down here at the bottom over to frame 162. And that just kind of starts me in the right spot. So it's hard to do with my writing pad. Close. Come on, Chris, you can do this. Okay, I'll go a few frames before. And then on the other side, see how I can drag this one right here? This will finish the frame. And so as I look, can you guys see how the basketball was bouncing there? So here it hit the ground, and I think maybe I'll stop it. I don't know, maybe about there. That should be enough. Okay. The next thing I want to do is on this number right here, number 1, this is going up one picture at a time. And that's a lot of pictures to analyze. That's way too many to do. It's overkill. So if you click on this number 1 and you change it, I'm going to have it go a different number of frames per second. I need my computer for this one. Why don't we make it go every 10 pictures maybe? Okay, let's see what that does now. You guys see how it's going up by 10s now? Now what I should be able to do is analyze. Okay, so see how this is right here now? This is now 10 pictures later, 10 pictures later, 10 pictures later, and back up again. I think actually 10 is too many pictures. I should maybe make it more like 5 pictures per frame. We try it again now. So here's he starting. 5 pictures later, 4 pictures later. I'm on 4 apparently. 4 pictures later. See how I can literally see it move one at a time there? It's kind of cool. What I'm going to need to do is know the exact slide that it hit the ground though, and that's a problem because as I'm going at a time here, here's where it was on the way down, I think. And here's where it's on the way back up. So even 4 frames is maybe too much. Maybe I should do it 2 frames at a time. One more time. So 2 frames later, 2 frames later. As I click through, we can literally see this thing. There we go. This is going to work better now. There. That's where it hit the ground. Does that make sense? So first I got to set that part up. Okay. I better sit here so I can see better. Okay. Next step we need to do. We need to, up here on this number little 10 thing right here, and by the way, you guys are going to do this at some point, so make sure you watch, and I am recording a video so you guys can do it again. The next thing you got to do is put this little bar right here and click on this and make a new calibration stick. Something in this picture, we need to know how big it is for a frame of reference. Okay? And what I'm going to do, I have to go to my computer for this part, is I have to go Shift, and I'm going to click whereabouts Brady started the ball, which was about right here. And I'm also going to click down here where it landed at the bottom. Can you guys see how that now made a blue stick on there? How far was it that Brady dropped the ball again? What did we say it was? Okay, so I'm going to write in here 6.5 meters. Okay, somewhere in this photo, I don't know if you guys can see it all that well, that's why I have the lights off, but somewhere in there, this now says 6.5 meters from where he dropped the ball. Make sense? Okay. Oh, where did the metal board? Here it is. Okay. It is, yeah, but I'll help you with it. So the steps were, get the video in here, figure out which frames you're going to go from, and figure out how many frames to go up by. I'm currently going up by 2 frames at a time. You could go by 1 or 3. Okay. And then you hit this frame right here. Okay. The last thing we need to do then is create what's called a point mass. Okay. And this mass right here, what I'm going to do is I'm going to click Mark by Default. Okay. I'll help you guys find this again later, but I'm making a video, right? So you can watch this again. Click Mark by Default. And then I'm going to start at the beginning. And literally what you're going to do is every single picture, I'm going to click where the ball is. So I'm going to click right there. That's the first picture. Then I'm going to click there again. And then here. And then here. And there. And there. And there. You guys see how every single picture, I'm clicking where the ball happens to be? Every time I click, it's 2 pictures further. There, now it hit the ground. Now it's bouncing back up, 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 bouncing back up. Yeah, it bounced pretty high, eh? I don't know if you guys noticed how high it bounced, but like it bounced almost halfway back up, eh? Isn't that cool? And then it's now about as high as it got again, and it's on its way back down. Okay. So something like that. And then eventually I'm going to run out of frames. You see how I'm like running out of frames down here? And now it's going to be back at the bottom again. Okay. We're now done. Okay. If you guys can repeat that, that's what I need you to do at some point. Okay. And if you're struggling with using the software, like I said, I'm making a video for you guys to see it right now, but I'll help you again. Okay. Now what we can do is do some analysis with this. This is where the tracker software is really useful to us. Okay. Over here, now that I've done doing all of this, I can make some graphs. Okay. Now currently this is a graph plotting x versus time. That's not a very useful graph to me. I'm going to change this one so it's not x, but it's y. Look at this graph. See how the ball went down, 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 down. What happened right here? It hit the ground, it bounced, and it came back up again. That's kind of a cool graph, eh? Does that make sense? Right. But I could change even more than that. I could calculate, rather than x, I could calculate its velocity. No, let's even go better. Let's calculate the acceleration. Okay? Now, this doesn't really work quite as well, because here's what happened. The graph was accelerating, accelerating, accelerating at the exact same rate of speed. And then, you know what happened right here? It bounced. This right here is where all of a sudden the ball bounced. And then gravity started accelerating it like normal again. And so I can make some graphs out of this. I could even do a velocity in the y component graph right here. Look at this. Here, this thing kept getting faster and faster and faster. Now I know it's going down, but here's why it's going faster. It's going faster in a negative direction. Because from where Brady started, wasn't the ball going downwards? So it started at nothing, and then it started going down, 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 faster and faster and faster. And then what happened at this location right here? It bounced, and so all of a sudden the ball started going back up again, and then the ball started coming back down again. That's kind of cool. Okay. Now here's what I need you guys to do. Okay. As part of your lab, can you guys find questions 6, 7, and 8? Okay. I've basically done this for you, and I'll help you do it again. Let's talk through question 6. Question 6 says we want to figure out the speed at which the object hits the ground. We want to figure out how fast was the ball going right when it hit the ground right here. So what I'm going to do is I'm going to go to the graph, like this table of values right here, and I'm going to change the table so that it's not x and y, but so that it goes with Vy, velocity in the y, up and down direction, and that's all I need. I'm just going to close this. Okay, I'm going to get a table of values here. And what we have to do is figure out which of these numbers is when the ball hit the ground. So I'm going to fast forward through my slides and see how I go one at a time, how it changes where it's highlighted right here. Okay, so I just need to look at the video and see where it hits the ground. You'll also see that this thing right here also tells me where we're at. I'm looking for where it is right there. So I'm just going to keep fast forwarding until we get to the spot where the ball hit the ground right there. That's where it hit the ground. Can you guys see down in this bottom corner right here? What was the velocity? When it hit the ground, the ball was going 12.49 meters per second. Down. Why is it negative? Because it was going down. Now, what did I calculate earlier? Didn't I calculate about 11? That's pretty close, isn't it? 11 versus 12? I mean, the only reason why it's off by a little bit is because I think we had to estimate that it was 6.5 meters. Okay. So what I need from you guys is I want you to redo what I just did here, okay? And I want you to print off this table of values and point out this value right here. One more thing, by the way. You know how you guys were trying to figure out when the ball hit the ground? Were most of you about 1 second? Look at the time value. It hit the ground at exactly 1 second. Isn't that kind of cool? Okay, let's try the next one. Again, using the exact same software, I've already done all the plotting. The next thing I want you to do is make a table of values for acceleration and time. So go to this table right here, and rather than doing velocity, do acceleration and time. Now, this one's not quite as good. It's going to go up and down. It's going to vary a little bit. But what I'm hoping you guys will see is that these numbers right here, first of all, they're all negative because the ball is accelerating downwards. But ideally, this would be about 9.81 all the time. Here it was 9.5. Okay, these ones right here, I don't know why it's off. Then it's -8, -8, -10, -11. Ideally, this would have always been very consistently -9.81. Now, I know a reason why it's not perfect. You guys know when I was clicking on the ball with my little thing right here? I wasn't very consistent, right? Like I just kind of clicked about where it was, but if I did it like exactly in the same spot, ideally we would discover that the acceleration was always 9.81. It wasn't, but it was in the ballpark. So that's number 7. And then for number 8, we're going to talk about number 8 later, but what we're going to try to calculate is how much energy was lost due to the collision with the ground. I'm going to go back and remake this a graph of y versus time. And you guys are able to see how this was the ball starting up here. It hit the ground and it bounced and it came back up again. Some energy was lost. I'm using my fingers for lost because it was lost to things like sound and heat. Ideally, the ball would hit this and bounce all the way back up to where it started, and that would have been like 100% efficiency. But would you guys agree with me that it only came out maybe about halfway back up? So it's probably only about 50% efficient. Next week, we're going to talk about efficiency, and we're going to use this graph right here to figure out how much energy was lost. Because clearly, it didn't bounce all the way back up to the top again. Yeah?
So with the graph, it shows that the slide that's around correct.
Oh, good point. Yeah, it looks like it went one more slide before that. That's a good call. My board turned off here. Yeah, I'm curious as to why. That's a good point, because I'm one slide removed. I think it's because I went backward slides, because you can see that I'm right here right now. So I think I was supposed to be 2 slides further, I think. Yeah, I think I just somehow clicked on this. There, now we're on the ground. That makes sense. So, okay, so I'm going to stop my video now, because that's all you need. Let me stop where my video recording is here.